Right, I'm just going to introduce, we've got a brilliant talker, Dave Murphy's coming to talk about energy and where the story has gone over the last few years on energy devices.
No, I'm not.
Practical free energy.
Practical free energy.
So I'm going to say, let's welcome Dave Murphy, because he's got a mic and I haven't. Thank you very much.
Okay, yeah, it is practical free energy. The idea about this is some of the things that we can all do, and just the idea that energy is basically all around us, and this idea of having to generate energy is almost ridiculous. So just a few things that anybody can go ahead and do to get power. So I'm going to start with, I don't know, this is a bit odd, I'm going to have to stand sort of to the side a bit, I guess. Let's start with the idea of the earth battery. And this is the simplest of all, okay? You literally have to just stick two stakes of metal in the ground and you'll get a voltage between them, okay? Simple as that. And if the two stakes of metal have to be basically different types of metal. It's a differential between those pieces of metal that actually generate the voltage. And what you can do is chain them together to actually get a decent amount of voltage. Here you can see just two containers of earth with I think is a copper and a zinc spike in each, and it's generating enough to drive an LCD clock. Okay, the important thing there is to get a good connection to the earth. So if you're going to do a proper system, you need something like I don't know, a car radiator as one of your earth points, because that has a massive surface area compacted in a small area. The ground also should be kind of moist, because in this I don't want to get too technical, so I'm not going to go use long words like electrolytes and stuff, but you know, if the earth is moist, that conducts electricity a lot better. So the spikes apparently have to be as far apart as practical, as you know, because if you have them too far apart, the energy that you get will be lost in the wiring that you have to use to connect them. So something like 6 foot apart is about optimum, I'd say. But literally, if you get a whole row of spikes and chain them together, you'll generate a decent amount of electricity, and that electricity will be constant. Just your earth is just providing you with energy constantly. So you know, just have an experiment. I mean, some of you might have come across using a lemon or something as a battery. Has anybody done that? Yeah, you just get a lemon or an orange or something and cut it in half, put 2 different types of metal in it, and put a meter on it, and you'll find power. A small amount of power, but it's power nonetheless. And you chain a few oranges together, and you can charge your laptop, charge your phone with it. You know. So just with this very simple bit of knowledge, you can just experiment, have a play around with it. So I'm going to move on to something a bit more sophisticated, and the idea of antenna to collect electricity. So the basic part of it is you basically have an antenna. As much as tall as you can make it, actually. It gets a bit dangerous, because if you make it really tall, you're in danger of attracting lightning strikes. But you make an antenna as tall as you can make it, and these symbols here, if you're not into electronics, are called diodes. And the interesting thing about diodes is that they let electricity go through one way, but not the other. Okay? So they look like little arrows. That means the electricity goes that way, but it doesn't go through that way. That's what that line is there to show. It goes that way, but not that way but not that way. So when the antenna picks up electromagnetic radiation, okay, this is basically how radios work. It picks up this electromagnetic wave and induces a current in the antenna, okay, a small current, but that current is what's known as AC. That means it goes from positive to negative to positive to negative in a kind of wave, okay. What these do, because they only let current go through one way and not the other, they turn that AC current into a DC current, and DC means it's only going to be negative to positive, and it will always stay that way. So the antenna receives this AC wave, and this is called what's known as a bridge rectifier. It turns that AC into a DC current, and this is a capacitor. Now, a capacitor is like a battery. It stores current. But unlike a battery, it stores current very quickly, it soaks up energy very quickly, and it lets it out very quickly as well. Whereas battery will store current and then let it out slowly. So with this little setup, it will start to charge this capacitor just from nowhere. And if this is a 50-volt capacitor, you'll end up after 15-20 minutes, you'll end up with 50 volts in that capacitor from the air. So you can get a bit more sophisticated with this. So with the addition of a couple of more capacitors in strategic locations and binding it to the earth, right, you can generate a larger current. Again, the difference here is you're getting energy from the sky, from the ambient atmosphere, okay, and you're contrasting it with the earth. There's that differential. Just like having two different metals in the ground generating current, you're getting that differentiation between the sky, which has, unlimited amounts of energy in it, and the earth. So you get that's that differential that causes a current flow. So with this little circuit, you'll get enough power just for this little circuit to charge your phone. This circuit is a phone charger circuit. Yeah, you basically connect the negative and positive to your phone. It will, after a couple of minutes, will start charging up. But if you view this little setup here as a module, so that equals this whole thing, yeah, then you can chain them together. In this case, there's a few modifications here. Not only do you have, there's your antenna, but you have an earth to the antenna, and you take a tap from, actually it's also quite important that you make the tap on the antenna to the earth halfway, and that goes into the top, and the bottom that goes to the earth also goes to the earth there. Just a little modification, but you will end up having a bank of batteries that basically will produce a decent amount of power, probably enough to rival a car battery. You stick enough of these together, you'll get a real decent amount of power, which is again constant, because the Earth will not change, the amount of power in the atmosphere will not change. You'll get a constant supply of power. This is how easy it is. It's kind of laughable that we're constrained to using solar power and wind power as the only source of alternative energy. Yeah? If there was research and actual development put into just earth batteries and antenna systems, yeah, there'd be enough power for everybody. So I want to give you an idea of this static electricity generator. I'm going to show you a little video now about a well-known effect that's very odd, but see if you can follow along. If anyone's got any questions, by the way, just feel free to ask.
Now I want to entertain you for the last 6 minutes with something amazing, something that is truly amazing. And it is a form of a battery that is mind-boggling. And the battery is right here on my left, on your right. It is a battery that produces an enormous potential difference. 10, 20 kilovolts. You see a schematic here on the transparency. You have a bucket of water here on the top, and you have glass, and the bucket of water is hiding behind here. Not that because we hide it from you, but that's the best place to be. And you see plastic tubing coming down, and the water can run out on the right, and it can run out on the left. It runs out here. There is some paint can, no top and no bottom. And you see this paint can here, it's completely open, the letter A. And there's another paint can on the right, there's a letter B. It's a conducting can. This is also a conducting can. And this water runs into another conducting trash can. And this water also runs into a conducting trash can. Now comes a key point. That this conductor here, A, is connected through a conducting wire with C, and the conductor B, the paint can, is connected with a conducting wire to this trash can D. You let the water run for a while, and you will see in between these 2 points here, sparks. Even when the points are as far apart as, say, 5 millimeters, when you're talking about at least the potential difference of something like 10, 15,000 volts, you will see the sparks. And you wait, see another spark. And you wait, and you see another spark. So this is a power supply. And there must be energy coming from somewhere. And so problem 4.1, which you haven't seen yet on your fourth assignment, is asking you how this works. I will demonstrate it today, and I will come back to it later. The way it works is actually quite subtle, but I want you to think about it. It's a remarkable battery, a remarkable power supply. As the water starts running, I want to draw your attention to the fact that you can almost anticipate when the spark occurs. Because the water at the very last is beginning to spread. It doesn't come out anymore just like a narrow cylinder, but it begins to spread. And then comes the spark. And then it goes back to running normally, and then slowly in time it will spread, and then comes the spark. So let us get it going. We have some light here. Marcos and Bill spent a lot of time getting this going. Marcos, do we have all my lights the way you want them? You're happy with that. There you see the 2 balls, which are really here. And let's first look at the sparks. So I will start the water running now. Let's just be patient a little bit. And let's see where we see in spark. Did you see one? Did you see the spark? Oh, you were not looking. Man, paying for this. Look at the 2 balls. Give it some time again. Have to charge up. I can already anticipate it's coming up. Coming up. Yeah. Did you see it? 10, 15,000 volts. Let's give it a little bit more time, and then we'll take a look at the water flow, which I can see close. We can make you see the water flow. Look again. It's coming up. Did you see it? I can see it coming up. I can make you listen by having my microphone near the water, and you can hear this water running. Really the sound to all of us. And now the sound changes. You hear change, and there's the spark. Once more. Just running. Spreading. Coming up. Yeah! Amazing, isn't it? I can make you see this water. Just stay there. We have 1.5 minutes left. So now you can see the water. You happy with the light, Marcos? You can improve on it. So look at the water. Ah, it was just spreading already. You can't see the spark and the water at the same time. So the water is running now normally. It's going to spread slowly. I will tell you when I see the spark here, but it's already, I can almost predict when it happens. The water is spreading now. Coming up shortly. Yeah, I saw the spark.
Okay.
And you immediately see the water go like this. I want you to think about it and explain this. This is one of the most remarkable things I've ever seen in my life.
So, that experiment was called Lord Kelvin's thunderstorm. Okay, literally, it's as you see, it was creating sparks of around 50,000 volts just with water falling between paint cans. 50,000 volts. But the current, the ampage was very, very low. So it would have given you, if you put your hand between them, it would have given you a sort of a little jolt, but it wouldn't have killed you. Yeah. Just like if you've ever touched or gone anywhere near the ignition and the spark, your spark plug on your car while it's running. Has anybody ever done that? Got a jolt off of that? Yeah. Right? That's interesting. It's the same sort of thing. It's the same sort of thing is happening there. Okay, you're getting from this experiment, you're getting a high voltage spark, but of low amps. And I realised that the reverse is happening in your car. You've got a 12 volt battery, so low voltage, but high ampage. Okay, power source that's going into an ignition coil and being stepped up to something like 40,000 volts. To cause the spark in your spark plug. So, and what you're seeing here in this diagram is the same setup that we just watched, okay? But instead of creating a spark between the two buckets here, we're taking that power and putting it into to a spark plug. That's the spark gap. And the other side of the spark plug going into an ignition coil, and then from the output of the ignition coil going into the battery. So we're reversing what's going on in your car. So we're getting a high voltage, low ampage spark here, okay, going into the spark plug, being stepped down to a low voltage, high current spark, basically, impulse. So that's enough to charge a battery. Yeah? Does everyone follow that? Audience participation. Yes, Dave? Well, this is the thing. It's about charging batteries. The thing about static electricity, yeah, we see it all the time. You rub a balloon and you'll find it will spark. But nobody's really ever found a way to use that energy. We all know it's there. But this is a way of actually using that energy to charge batteries. So if you've got a source of water, and you saw in that experiment he used just a tubing, but you could use a hypodermic needle to get that stream. It's not the volume of water that causes that spark, it's the fact that the water's going through that environment that's creating that energy. So you can use a hypodermic, you don't need an awful lot of water, just use a very fine stream, and you can set up banks of these and just have this charging batteries, just with water. Yeah?
So is this the same sort of energy field that a water dowser would be tapping into on the pump?
I would say not, actually, because the way I see it, if you heard my talk yesterday, I actually mentioned this. I think, you know, as humans, or all animals on this planet actually can sense water innately. We are not aware of that sense in ourselves, and we still have it, but we can only access it subconsciously. And what happens when you're dowsing is that you know, you subconsciously sense the water, and your subconscious makes micro movements of your hand to cause the rods to go together, or whatever. Even if you're using a pendulum, you know, you sense it, and your subconscious makes you actually make a sign with the pendulum.
But isn't it the flow of water is creating an energy field?
That's, yes, that's actually that. The pyramids. One of the suggestions is the pyramids are a power source, and underneath the pyramids there is a flow of water. And I was going to say, when we were talking about the Earth battery, yes, it's good to have the Earth moist, but what's interesting would be a flow of water. And as we've seen, the flow of water there causes electricity to be formed. So, you know, it kind of lends that credence to the idea that the pyramids are a power source, that they had a water course going underneath the pyramids, flowing past it.
Most pyramids have water courses through.
Do they? Yeah. It's it starts to look like they're more than just tombs. They're actually more of a power source.
The walls in the pyramids, especially the bottom, crystal, are actually making
right. Yeah. This is the thing. You know, that's this ancient technology that you know, we look at it and we can't actually see any technology. Well, the technology is in the structure. It's in the physical makeup of the structure. So we can't find any. We're not going to find you know, PP3s, you know, AA batteries lying around. You know, they were generating it from in a natural way, and I'm not even sure that it's electricity we're talking about, because I'll get into that in a little while. But this is the point I'm trying to make here, is that this water, falling water, generates or attracts electricity, and we can actually use that in a practical way. As I said, you've seen it done. You saw how simple it was to start generating sparks. Yeah, you can do this at home. So you can also mix and match a few of these ideas. Again, you've seen this before. This is the antenna with a diode, just to, rather than rectify the AC that's coming in completely, you're doing it a slightly different way, just by letting only half the wave through this diode. Again, into a spark gap. You've got a spark gap and a capacitor. So the capacitor's charging up, as it does, and then when it reaches a high enough charge, there'll be a spark, and then you can take that spark and step it down and charge batteries. So it's a kind of mixing and matching of all the things we've seen so far. Again, because what we've got here is the conditions for a massive battery. You've got the Earth as one node of that battery, and you've got the atmosphere as the other. It's a battery. It's one that Tesla himself basically used to better effect than anybody else. That using the Earth as a conductor, as a battery that we could all tap into. If anyone's ever heard of Wardenclyffe Tower, his big experiment that got shut down by JP Morgan. Literally, he built a massive tower that was going to transmit electricity all around the world. And literally all you had to do was have a little antenna to pick up this power. And you'd have unlimited power. Everybody would have unlimited power. So as I said, the Earth is one side of the battery, and the atmosphere is the other side. So as I said, this is not very difficult. We're not talking about masses of components and lots of confusing electronics to do. Anyone can do this. Oh, I'm going backwards. Okay. So now I want to talk about something that I'm playing around with. It's called a Bedini Energizer, and it's a bit too loud or anything. But so what it is a magnetic motor, and what you're seeing there is a little build video of my one. It's a magnetic motor. You've got a rotor with a whole number of magnets around the outside and coils around that rotor, and literally it spins the motor around. You actually power it with a car battery, and it spins the rotor around, and it generates more power than you basically put into it, and it charges up. This one particularly will charge up a bank of 20 car batteries from one. What it was named after, it's called the SSG, Simple Schoolgirl Circuit, because it was named after the fact that a 10-year-old girl wanted to do a school project. Not school project, it was like a science fair type thing. And she was neighbours with this guy, John Bedini. And he basically sketched out on a piece of paper this little circuit and said, go and build this. And what she did, she built this thing very, very similar to this, but with one coil and one small circuit and a bicycle wheel with magnets strapped to the outside. Okay, and with this little contraption, she had a light bulb running from a little 9-volt battery for 2 weeks, because this thing would just keep charging itself up, and she kept this light going on for 2 weeks, whereas it would have lasted for a couple of hours normally. So yeah, this video is when we first got the 10 coiler running. And it was really exciting because the battery we had it on was a big tractor battery, and we didn't have the connection to it on properly, and we got Tesla style sparks coming off of this thing. It was just like and we were watching how it was being charged up, and we could see the charge building. Like it was like 11 volts, 11.5 volts, 11.7, 12. It was like, oh, this is going too fast. So this is the circuit, and this is actually the schoolgirl bicycle wheel on top there. So this might be a little sciencey, but and electronicsy, but I'll go through how this circuit works. Okay, so there are 2 coils on this coil, and this is one I'm winding actually. I'm going to go back to that. This particular one has 3 strands of wire, all sort of twisted together and wrapped around this spool with welding rods in the middle. Okay, so that coil is represented here, but this one's just got 2 windings on it. Okay, so when one of these magnets comes close to this coil, what it does is induce a small current in this coil here. Okay, and what happens is that current comes through here and goes into this transistor. And what a transistor is like a switch. It's a very clever switch. If you put a little bit of current in here, in this side, it opens a pathway for current to go through here. That's all it does. And if you put a little bit in here, this switch opens up a proportional amount. So if you put like 0.5 volt in here, it'll let 5 volts through there. If you put 1 volt in here, it will let 10 volts through. Yeah, so it's a proportional switch, kind of. So it induces a current here and opens this switch, which lets a current go through this coil here, which magnetizes these rods and then pushes the magnet away. And that's what starts the wheel to go round. So it pushes the magnet away, and as the magnet moves away, the current disappears here, the switch turns off, okay? And now this is the weird bit, okay? When there's a very strange effect people in electronics know about, we all know about it, but we're only taught that we have to protect our circuit from it. It's called back EMF. And what happens is, if you have a coil with a switch and a battery, and you energize the coil, when you turn that switch off, a strange thing happens. You get a spike of energy higher than you had in the original circuit, go backwards through the circuit. Okay, so here we've got a 12-volt circuit with the battery here. Okay, when the switch turns off, all of a sudden you get a 300-volt spike go backwards through this circuit. And as people in electronic engineers, we have to put something across our switch to protect this transistor from being burnt out by 300 volts. So we have to, in this case, I put a neon bulb, so that if the power goes through there, it will actually go through the neon first and not through here, and destroy my transistor. So this weird effect called back EMF is a massive spike of energy from somewhere that goes backwards through the circuit, and we've got this diode here. Remember I said a diode will let power go through one way but not the other. So this diode is shunting the power that's going to go backwards into your charging battery. So what you end up with, as these magnets go past here, you just get these pulses of 300 volts or more sometimes getting fired into these charging batteries. So does everybody follow that? Yeah, have I been sort of, yeah.
Remember there's ladies here that might not know science, so can you see a piece of electrical equipment so we've got an idea of what would be run off?
Well, this is the thing. This is the thing. What we're doing here is talking about charging batteries, because it's the simplest way of dealing with this. Once you've got a charged set of batteries, you can get this thing called an inverter. And I've got one in my van, which is a 5 kilowatt inverter. Okay, 5,000 watts of power. Your house would typically run between 7 and 10. So maybe from 5 to about 8 kilowatts, depending on what you've got in your house. If you've got a 5 kilowatt inverter and you are kind of economical on some of the things you use, then that's enough to power your house completely. Everything in your house running off this inverter. Okay, if you've got a bank of say 10, 20 car batteries running off of one battery here, and I'm going to show you something a little later on, but that's enough to keep your house powered.
And are you leaving the energy in the battery, or you put it into storage? What are you using the excess? You put it into something to store it?
Well, that's what a battery is. It's a storage device for the power. Sorry, say again? Oh, all right.
From my understanding, I went on a solar power course, doing on solar panels, because there was a guy.
Sorry, can you speak up? Sorry.
Yeah, there was a guy. I went and done a solar panel course in London. There was a guy, the lecturer, who was actually teaching people to sew these solar cells on cloth.
Yeah.
Because he was doing a project out in Africa to teach the Africans how to produce their own solar energy. But inverters and deep cycle batteries.
Yeah.
You would take all the power from that to power your house. Or
Yes.
12-volt,
Right. Yeah. You can actually change your house to a 12-volt house if you want. I mean, that's one way of going, and there's probably a better way of going. But if you wanted the minimum change, you could just get one of these inverters, which is really just stepping up 12 volts up to 240 volts, okay? Which is, if you go to a completely 12 volt house, it's an unnecessary step. But you know, if you want to keep all the things you're using, then you need an inverter to step up that 12 volts to 240. But if you have, you know, deep cycle batteries, 100 amp hours each, yeah, we got 10 of those batteries, you've got 1,000 amp hours. So the thing will last for, if you're only using 1 amp, it'll last for 1,000 hours. Sorry.
When I saw on the website these, I did try and track them down. I noticed there was somebody manufacturing them in the States.
Yes.
About $4,000, I think.
Well, that's the one I showed you, the little video that was running. That's one of them. That's a 10 coiler from John Bedini himself.
And is that, can you get them in the UK?
No, you can't.
Why?
Because John Bedini is in America.
Well, surely
Custom
bring
stops
them
it.
in America.
I did. I ended up having it delivered, but they stung you on import duties and stuff as well. So, yeah, but you know what? It's not hard to make yourself. I've just started winding coils for another one. So I'll get into that in a little while. But yeah, sorry.
There's a leisure battery, you know, like you use in a caravan or a camper van. Is that more possible?
Well, yeah. If you look on batteries, I'll tell you what the capacity is, and it'll be in amp hours. So if it's 100 amp hours, that means at 1 amp, if it's delivering 1 amp, it will last 100 hours. But if it's 10 amps you're using, it's going to last 10 hours. Yeah. So yeah, if you're going to have a bank of batteries, you want to make sure the highest capacity you can manage.
The difference between deep cycle and car is the car is very much more sharp for energy. Deep cycle, store it and release it slowly.
Slowly, yeah.
That's why they're more expensive. That's the difference between deep cycle and car. Cars are okay, but they will break down. They won't last as long.
That's right. Yeah.
If you have 10 batteries, how do you go about maintaining them?
Sorry?
Batteries, how would you maintain batteries?
Well, I was going to go into this a bit later, but actually this design, because it's being charged up in a different way than most other chargers work, those spikes of high energy, yeah, actually recondition the batteries. They make the batteries better than they were when they were first manufactured. You know, they end up working at 110% capacity. This is, and as I say, I'm going into that later on, but, oops, there we go. This is my prototype.
Bedini Energizer. It's basically the same familiar circuit that everyone else is using. The only difference here is that instead of using the pot, as a pot and a resistor, I have a 680 ohm resistor in there instead of the pot. Otherwise, it's pretty straightforward. Okay, I'm actually trying to charge a car battery, which you might see is under here. I've just hooked up my battery charger.
No, it says 45% there.
So I can tell what the percentage of battery charge is. It's got a good indicator on there. So, here we go. Let's give it a go. Okay. Let's give it a spin.
Sorry?
Noticing it doesn't have a very high RPM. It's based on a hard disk platter.
The circuit's just that big.
I guess I'm just guessing that the aluminium frame there, and the fact that it's got it's essentially got a motor in the back there, so the magnet in the back of that motor is probably interfering with it. But anyway, it's off it goes. looking at a voltage on the primary battery of 12.8. I'm going to look at the voltage on the, well, I can't actually see it here. Voltage on, probably can't see that, the voltage is 12.28 on there. And
so that's about a minute later.
Almost, it's almost immediately
52 volts.
Sorry? Shut up to 53% now.
Sorry, 52 volts.
53%
in a minute.
Good, I'd say. There it is. Leave it on charge for a while. See how we do. One weird effect. Now I'm pretty sure everyone has noticed this. When I connect the pot up and increase the resistance, the motor actually stops working, but I get a very strange resonance effect, and the circuit seems to be self-sustaining. I'm going to reconfigure this and show you later on, but it's a very, very strange effect. I'll show you that later. I actually burnt out the transistor of my original design. I was messing around with relay energizer, and I tried to combine the outputs of the two and ended up blowing up the transistor. So I've rebuilt it. Unfortunately, I don't have another 10k pot, so I've used the 5k, so it doesn't give me quite the same results. I'm just going to show this very strange resonance effect that I came across the first time. Now, I turn the pot all the way down, so basically all I've got as resistance in the base of the transistor is 100 ohms. So we're going to start it up. Okay, runs as normal. As I turn up the pot, turn up resistance, notice it slows down and stops. But if I'm going to get this quite right, there you go. Now it seems I've started the kind of magnetic resonance, basically like it's like, I think it's like audio feedback, that the magnetic flux from the magnets going around started or induced a current in the trigger coil, which then induced a current in the power coil, and the collapsing magnetic fields induced another current in the trigger, and so on and so on. And you're getting I believe you're getting a feedback response. And the interesting thing is, as I increase the resistance, you can quite hear it, the frequency goes up. And again, I've only got a 5k here, so I can only get this particular frequency out of it. My previous version, the frequency went up a lot higher. Now I'm just going to try and get a nice resonance there. Now the only reason you're hearing this sound, I guess it's an accident really, is because I'm using this hard disk platter, which is like a metal platter. If I touch it, you can see it's literally the magnetic flux in the coil that's actually attracting and repelling the magnet and vibrating the platter. You see, as I've moved the magnet away, you don't hear the noise so much. If I rotate it back, there you go. I have to say that it's not a badly designed circuit that's causing this. The circuit is correct. The only difference is that I've increased the resistance in the base of the transistor. The circuit is kicking out voltage here. I don't have a voltmeter hooked up to it. However, if I disconnect the charging battery, notice that our little neon here is lit, proving that there's at least 120 volts kicking out here. So we can tell that even though the wheel isn't spinning, we're getting a motionless energizer effect. So that was actually my prototype that when I first started on the Bedini trail. I was just playing with it, playing that very simple circuit, and as you saw there, I made a mistake. I put the wrong value resistor in there, and all of a sudden the thing started working without the wheel running. And yeah, it actually sat there and kicked out power. So right now, as I showed you this, I'm actually winding coils now to do a multi-coil version of that motionless one to power my motorhome. So you know, watch this space. So that circuit that I showed you earlier on is literally this part. It's just this part, and the 10 coiler I showed you earlier is literally the same circuit, just replicated over and over again. This is so simple. Just that one simple little circuit, yeah, just replicated over and over again. In the case of that big 10 coiler, 80 times. There's 80 different circuits in there. Okay, and each circuit is just kicking out spikes of energy. So as you see, it's very simple to extend and expand. And later on, I'll show you that the guy who sold me the kit, the 10 coiler kit, he's made a 30 coiler, and you'll be able to see what that does. And this is it, actually. This is the video.
Okay, very crudely connected.
What we're looking at here are cell tower batteries. 2,000 amp hours. Okay, they stand about that high, that wide.
And you can see up here.
Oops.
0.6.
And they're being charged by these two little batteries.
Yeah, these batteries right here have not.
There's 24 of these cell tower batteries.
These have been on there for.
So these are two input batteries. These two little ones.
So how big are
And
these
now we're going to
batteries?
turn on the switch.
The big one, the ones he's charging up.
These batteries, which are now.
They're that high, that round, and they're 2,000 amp hours. So one of those batteries will give 48 volts for 2,000 hours at 1 amp. So one of those could power your house for I don't know, maybe a week.
We're not pushing it very hard at the lower voltages. But you can see the back part bouncing around.
And what he's done, because that motion, that revolution of these rotors, are essentially just free. You're not using it for anything. What he's got at the back are coils that will charge up the charging battery, the powering batteries. So the thing would run almost forever on its own, because the input batteries are being charged up by the ones at the back.
Be fully charged anytime soon. But when you're talking about 10 amps, 11 amps, 12 amps maybe, at 22 volts.
So can you see the power of this thing?
Going in.
Those two little batteries, keeping that massive bank of batteries,
I would say,
which will probably keep a neighbourhood going for a week,
Yeah, being charged up by those two little
So yeah,
batteries
that's
there.
what you want to do with these systems, is charge up a bigger
Sorry?
battery.
There are some challenges to do that, though. This is the
only
thing.
problem is you can see the
And
neon bulbs are all
I'll
on.
speak about that in a little while, actually.
These are the neon bulbs here.
But anyway, this.
Now we have resistors.
It was just to show that literally this Bedini Energizer is extremely powerful. Just those two small batteries being able to charge up. And sorry, I meant to mention that there are 12-volt batteries, these two little input ones, wired up in series to give 24 volts. So that wheel was being powered by 24 volts. But what was coming out of it was enough power to charge up all those 24 cell tower batteries that run 48 volts each. So it doesn't seem to make sense, but yeah, it's very powerful.
John, is there any...
Dave.
Oh, sorry, Dave. Is there any practical problems with the Bedini Energizers or power house?
The practical problem there is that, the batteries are being charged, but not with electricity. It doesn't seem to be electricity as we know it. Okay, it's some other form of energy. So you can't really run the inverter off these batteries while they're being charged, because there's two types of energy going on at the same time, it seems. And I don't know what's actually going on, but Tesla, when he was doing his experiments, was coming up with a form of energy that wasn't electricity, but somehow behaved somewhat like electricity.
But he was calling it radiant energy, wasn't he?
Radiant energy, yeah.
So can we power a house?
You can. I'm saying John Bedini powers his house with this bank of batteries that he keeps charged up with his 10 coiler.
Basically, you're using the Energizer as a converter.
Yeah, what you do,
An inverter.
what you do is you have two banks of batteries. You charge one while you're using the other, and you switch between.
And you switch them over.
And
Yeah.
you automate switching?
Yes.
You can.
Yeah.
Yes, you can.
And so what, sorry, the next question might be a silly question, but what has stopped this coming in practice? Why are we not doing
Well, it's not stopped it. There are people in America who have already got houses that are being powered by systems like this and others. But in the mainstream, you're not going to get it.
It's not coming into the mainstream. If it ever comes into the mainstream, then the problem is whoever comes out will either be discredited. First they ignore you, then they discredit you, then you win. But a lot of them they're killing off as well. So or they're buying
there is an example.
Sorry, could we just have what that man was saying to people?
Yeah, I mean a lot of people have come up with these kinds of things before. So first, the powers that be, if you will ignore you. So they don't want this technology out. If you do get too big, they'll discredit you. Otherwise, they'll try and buy you out. So there were a couple of guys in Australia who came out with a similar kind of technology. And all of a sudden, they said that they'd have a home generator within a year or something. This was on the net. And then you never heard about them. You don't even know. I've never seen.
No, it's Lutech, the company, and they disappeared.
They disappeared. Nobody knows where these guys are now. So they've either been bought out or bumped off. I don't know.
There was a story just recently, in the last year, of a guy in Glasgow in a council house who disconnected his electricity, and he had a free energy device powering his house. And the council broke in and stripped it out. And they took him to court.
Why?
And they said he's making, generating his own electricity in a dangerous fashion. So yes, they're making sure that you can't do this. You can't generate your own power. Yeah.
You can.
Well, you can. They're trying to make it that you can't legally. They're using this legal thing to say, well, it's illegal now, so you can't do it. And they'll use their attack dogs, with uniforms to stop you. Sorry.
Speak about dangerous fashion. There are reports on the internet that they're building mini nuclear reactors with metal cooling, liquid metal cooling, to energize their underground cities they build. if it is true, what is dangerous, and why are we not getting on the level to...
We've been lied to about nuclear power. If you go on the internet and you'll find a kid, a 15-year-old kid, who built a nuclear reactor. He collected, nuclear material from smoke detectors, and the fluorescent material on old clocks. Yeah, you can collect that stuff, scrape it off, and dissolve it, and you'll be left with some nuclear material. Yeah, he built a nuclear reactor. This 15-year-old kid. Actually, the source of his information was a book from a Boy Scout book from the 1930s that said how to build a nuclear reactor. This is a thing we've been lied to. There's a guy called I've forgotten his name now. No. It will come to me. There's a guy who was a nuclear engineer in the early days when they were first building nuclear power stations. Okay, and his testimony was that when they were working this place, before health and safety came in, they were walking around with plutonium rods in their pockets. They knew that as long as they they kept them apart, and they didn't allow them to reach critical mass, otherwise there'd be a big blue spark, a big blue flash, but as long as they kept them apart, they were safe. They swam in the containment pools. This guy even ate some uranium. He says that all of a sudden these people turned up and said, "Oh, okay, you're going to have to wear these badges that show you if you've had a safe dose." Safe dose? We've been playing around with this stuff for ages. None of us are sick. None of us feel bad or anything. But they impose these limits, and anybody who said otherwise got fired. Anybody who said no, this is rubbish, they got let go. This idea of dangerous nuclear power is somewhat of a fraud.
What about radiation sickness?
Well, okay, this is where I came in and thought of something odd, because I was talking to a guy in America, and he said that he'd just come back from visiting Hiroshima. And I was like, what? Isn't that like a nuclear wasteland? We're told that, when there's a nuclear explosion, the land's irradiated for thousands of years. But Hiroshima is a thriving city, and it's a healthy place. Chernobyl is now that there's nobody there, the wildlife has gone crazy. The wildlife is healthy. There are wolves that have come back into that area, and there's actually a whole bunch of old women who decided they're not going to move, and they're in their 80s and 90s, and they live in the contaminated zone, and they eat the food grown in that zone. We've been lied to.
So what do you put down to Fukushima?
We're just told stuff, aren't we? We don't know what's actually going on. But what I know, the name is on the tip of my tongue. Windsor, I think his name is. It's gonna bug me. I'm gonna wake up at 4 o'clock in the morning and go, that's it. Yeah, I know. But this guy basically has, for me, blown the lid off of this, because, as I said, it's not what we've been told. Falsehoods here. It's all lies. Something else is going on.
Dave, what about the radium dial company then, and what happened to all the workers there?
Again, I don't know. I'm saying that there's something fishy here. I don't know. I'm not going to go into conspiracy theories. But I know that there's something not right about what we've been told. And something else. Einstein would say about nuclear power. It's a hell of a way to boil water. And I've always wondered, what does he mean by that? It's a hell of a way to boil water. We think of nuclear power stations as like the peak of our technological power here, okay? But when you look at what a nuclear power station is, it uses nuclear material to heat water and power steam engines. 19th century technology. Is that the best we can do? I don't think so. The awesome power of the atom, yeah, which is a power source in itself, we're using it to boil water. Yeah, think about that. Anyway, so you started me on a rant. So, here are the surprising results from the Bedini Energizer. Now, I wanted to bring the Bedini here and show you it working and stuff, okay? But when I went round to collect it, I discovered it wouldn't fit in my van. I couldn't get it in the van. It had all the windows out and everything, and it wouldn't fit. So I'm sorry. But yeah, obviously it charges a large bank of batteries from one single battery. Yeah, as I said before, it reconditions batteries to better than they were when they were new. They start once you've run them through charging cycles, 1 or 2 charging cycles, you start to notice that they start holding more energy. You know, they're rated at around about 13 volts. Yeah, you end up with like 14, maybe 15 volts. You know, just amazingly. If you've got laptop batteries, now if anybody's used their laptop for any length of time, they find their battery efficiency starts to go down to the point where, you know, they last like 5 minutes, you know, where they used to last 5 hours. Yeah, when you put one of those dead laptop batteries on the Bedini, they charge up to new, and sometimes better than new. Oh, this was odd as well. There's a guy on YouTube who's showing his Bedini working, charging up a battery. And he's got one of those temperature meters that uses a laser, yeah, and he's pointing at things. He measures the temperature of the ambient air around and the walls and the bench, and they come out around about 60 degrees. He measures the battery that's being charged, it's at 49 degrees. So rather than you know, the usual charging method that ends up heating the battery, this one cools the battery. Very odd. And I mentioned about the rotor, yeah, that when you got the thing spinning, yeah, that's literally just a kind of effect. You know, and you don't really use that. But when you do use that rotor for anything, say you put a fan on it, it will try to slow the rotor down because of the drag on the fan. But placing some load on that wheel actually makes it draw less current from the input battery. So the more you load that wheel, the longer it's going to last. So you can actually use the wheel to do actual work, and it will cause the whole setup to last longer. That's very surprising. But there were more results.
Sorry, Dave. You said about the guy in Glasgow with the council place, whatever.
Yeah.
The council came along and said, "Oh, you can't do this if it's not safe." Was he in the council house?
Yeah.
Yeah. So what's to stop us from doing it then if we're in private?
Well, I don't know. I don't think there is anything to stop you. But you see, if you disconnect your
There's nothing to build in there. It's
Part
Part
P.
to build it. There's nothing to
Yeah,
build
Part
it.
P wiring. Part P building, Rachel. Part P.
Oh yeah, that's the other thing. Yeah, they might come in and say, "Oh, your electrics aren't up to code," and they'll. You could run on 12 volt, but again, you don't know. They don't want us to be energy independent.
Oh, cool. So we get questions to the end.
Yeah. All right. Yeah. Sorry.
Limitations of size.
Okay. So above the surprising results, we got some unexpected results. The thing runs better at night. So when the sun is not in the same side of the world as this thing, it runs better. Something about the sun's magnetic field interferes with the operation of this motor. And plants go crazy around this thing. We had this running first of all in a farmhouse, okay, and in this barn we had all sorts of plants which were on their last legs, including an African violet, which doesn't really grow very well in this country. Okay, while this was running, and we had this running for a long periods of time, yeah, that African violet just flourished and grew and you know, bloomed. And then when we disconnected it and sort of dismantled it, moved it, this thing died. Just amazing. Now my friend Nolan, I gave my Bedini to because he's a prodigious experimenter. So he's got it in his garage, and he's been doing all sorts of experiments with it, and he's discovered that the efficiency is different according to who's near it. And he's watched it. He's watched the efficiency go down when somebody in particular approaches it. You know, as they approach it, the efficiency goes down. As they move away, it goes up again.
That's some sort of negative effect on it.
No, this is the thing. He also says that there's a good feeling he gets while being around this thing. And
does the machine pick up that someone's negative?
well, it picks up something about people, because when Nolan is playing with it and he's doing his thing with it, it's running, you know, really, really, really well. But when somebody else, and we haven't really sort of experimented with some evil people, you know, but maybe we should. But when somebody else, you know, starts the thing going and whatever, it doesn't run as well.
But we are energy, aren't we?
We are energy. We are energy. So I think maybe it's time for us to change our approach to what energy is, because more is going on than we've been told. As I said, Tesla, when he was playing with electricity, he was discovering that what he was generating wasn't electricity. It was something else. It was something he could see moving across the top of wires rather than through it or whatever. It was something that when he was generating electricity in one area, he was getting shocks off of door handles throughout the university. And the further he was getting away from it, the stronger the shocks were. So there's lots going on that we've not been taught about. And they say that energy can't be created or destroyed. So why are we generating electricity? How are we generating electricity? What we're seeing is that electricity might not be what we're really supposed to be getting. Electricity seems to be a byproduct of the real energy. And consciousness plays a part in it somehow. What if the real energy is attracted, not generated? So what is energy? Yeah, we've been told about the 3 states of matter, you know, gas, liquid, solid. But there is also a 4th state. It's plasma. Now, plasma, I mean, it's like fire. You know, fire isn't a physical thing. It's a state of something. We don't even, you know, you ask a scientist, what's fire? They'll tell you, describe it, but you can't really tell you what it is. It's a plasma of some kind. It's not part of the 3D world as such. It's energy. As you go up to the higher states of matter, you end up in states of energy. And what it seems to be, and this is my feeling here, that as you go up the higher states of matter, you end up in a state of consciousness, which is what we are, you know. So perhaps we are the energy. Now, I was talking to a friend at another festival. My friend was actually supplying the power to the tent, and we were chatting about Masaru Emoto. Has everybody heard of him? Messages in Water. And how his experiment with getting water and placing a label over the container that says love and happiness and peace and joy and whatever, that affects the energy of the water and infuses that energy, that water with that intention. Okay, he was talking about that, and he told me of once he saw that for the first time, he decided to do a little experiment of his own. He got a dead battery. Got this dead battery, wouldn't hold a charge. He put a label on it that covered up the writing that was on the battery, and he wrote 14 volts on the battery. Okay, put it up on a shelf, and every so often he'd take the battery down and feel 14 volts, sit there and intend 14 volts into that battery. Did that for a couple of weeks, and a couple of weeks later, put a meter on it, guess what? 14 volts. What if we are the energy? What if we're using metaphors to create energy, but we are the ones that are doing the creating? The energy is all around us, and we are a focal point of energy. What if, okay, I'm going off into a bit of metaphysics here, but everything in this world starts out as an idea in somebody's head. Just an idea. Like if you wanted to make this chair. I want to make a chair, and I design it in my head, okay? Now, we think that when we come to build that chair, you know, we use our hands, we cut down a tree, we plane the wood, we do all this. There is no objective universe out there. This is all ultimate potential, okay? We don't actually see the real world out here. We get it translated to us by our brain that's only receiving electrical signals. What's out here isn't what we're seeing. So our perception is that we're using our hands to build this chair. But what's actually happening is a manipulation of energy, yeah, at some level that we think we're controlling by a physical interaction, but we're actually manifesting, building this chair out of energy. Do you follow that? I mean, yeah? Yeah. And this idea that a guy can just get a battery and put a label on it and put his intention on it to hold a charge, charges that battery. Whereas we think that we need to get this box and plug it into a wall and put leads on it, and that charges the battery. No, it's our intention and our expectation that does it. But we need some kind of lever to do it, some kind of tool or metaphor to do it. Yes?
A little experience I had. I went to an acupuncturist in London once, quite a few years ago, and he was trained by Tibetan monks, and he really knew his stuff. And he opened up my senses, and he explained it that when we are born, we're bristling with all the senses. But as we go through life, our senses are closed down. We go to school, we do this, we run down. We reawaken our senses. And some people would think I was mad or experienced, but I do experience a lot of energies all over things. I think it's very easy to keep a closed mind. You know, there's a lot out there we don't understand.
Yeah. Since my talk was yesterday, actually, that we have, according to the Sufis, 360 senses, not these 5 dull ones. And we've just been taught, no, that's all you got. That's all you got. You know, get used to it. But you know, we know about these senses, but we just take them for granted or just ignore them because they're not in our radar. So how much energy is all around us?
Most people think that the vacuum is empty. But for internal self-consistency of quantum mechanics and relativity theory, there is required to be the equivalent of 10 to the 94 grams of mass energy, each gram being E equals mc squared kind of energy. Now that's a huge number, but what does it mean practically? Practically, if I can assume that the universe is flat, and more astronomical data is showing it's pretty darn flat. If I can assume that, then if I take the volume, or take the vacuum within a single hydrogen atom, that's about 10 to the minus 23 cubic centimeters. If I take that amount of vacuum, and I take the latent energy in that, there is 1 trillion times more energy there than in all of the mass of all of the stars and all of the planets out to 20 billion light years. That's big. That's big. And if consciousness allows you to control even a small fraction of that, creating a Big Bang is no problem.
That's what quantum physics tells us. There is so much energy in everywhere, in everything. And as he says, consciousness controls it. He says some of it, but I like to say it controls all of it. Because it is it. Yeah, you can say?
What is electricity and how is it defined?
Yeah.
What's the definition of energy? And then would you like to comment on how inadequate those two are?
You're looking at me like I'm an expert, yeah?
I'm a go at it, but I'm sure things.
As I said, I think electricity is a mere byproduct of the real energy, and the real energy is everything that makes up this 3D universe. Everything is energy. When we think that there is separation between us, that the vacuum is empty, what we just said, the vacuum isn't empty, it's bristling with energy. Everything. And electricity is you know, it's a kind of like hokey byproduct, hokey sort of, and we've built our whole technology around this stupid byproduct, and we've been told that is the energy, that's what we've got to generate, and it's keeping us away from the real energy, and it's because that this hokey byproduct will allow these toys to run, and they're all toys. All our technology are toys. They're like, you know, the coloured beads they bought Manhattan with. They're not. They don't do anything for us. They might do funny, clever things, but the toys are actually keeping us away from the things that we can do naturally. As I was saying in my other talk, that we have abilities that allow us to do anything and everything and more than all of our technology will allow us to do, and do it better. But we've been suckered into buying into all these toys and letting them control our lives. But all I'm saying is that it's a byproduct, and the real energy is consciousness. Somebody else had a question? No? Okay. So we're in a situation like this, you know? A fish saying, how am I going to generate water? He doesn't realise that water's all around him. Now, as I said, the idea I'm proposing here is that we're 5 minutes. Okay, I'm going. The idea I'm proposing here is that the energy is
generating too much electricity.
is from us. It's our intention that's creating this, and we're just using crutches to find a way to access that. So I'm going to finish with another little clip from the same guy that I just played a minute ago. Something to make you think about it.
We took two simple black boxes like this. Inside is a very simple electric circuit with a few diodes, oscillator, EEPROM, some resistors and capacitors. Basically that's it. We wrapped one in aluminum foil. We put it in an electrically grounded Faraday cage. The other we set on a tabletop around which 4 very well qualified meditators, highly inner self-managed individuals sit. And they go into a deep meditative state. They cleanse the environment. They make it essentially a sacred space using their mind cleansing procedures and their intentions. And then one of the four speaks the specific intention for this device. The intention is to influence a particular target experiment. Might be to increase the pH of purified water by 1 full pH unit, or to decrease the pH by 1 full pH unit. We've used these devices on all those experiments and have been robustly successful. In the meditative process, then after one speaks the particular intention, it's held various ways by the four for maybe 15 minutes, and then so be it, it's let go. And then a subsidiary intention is stated to seal that imprint into the device. We take one of these devices with this aluminum foil, we put it in a soft package, we put it in a FedEx packet, we ship it 2,000 miles away to the laboratory we were using up in Minnesota. And as soon as it arrives there, it goes into its own electrically run Faraday cage. The next day we do the same with the control. The experiment is running, and basically then one just takes the device out, sets it beside the experiment within 6 inches to a foot, and turns it on for a period of time. That's it. Now, we learned over some period of time that there was another factor. We found that the use of these, we call them intention imprinted electrical devices, the continued use of this somehow conditions the space to some higher level of symmetry. And we start getting new phenomena. That is, the devices work. That is, the pH, which is normal, starts rising 1 full pH unit, if that was the imprint, or starts dropping. If you go 1 full pH unit or beyond, you're dead. I mean, that's what it means to a human.
So, what they did, they just imprinted some meaningless electronics. They just made up a circuit, didn't do anything as such, but they imprinted that circuit with an intention. And that intention made the thing work. Maybe we've got to start thinking differently about this idea of energy. We are the energy, and that's what I have to say.
Lynn McTaggart.
As I said, Dave's one of the original men who stared at goats, you know, questioning the vernacular, the terms we use, you know, because